Hello everyone, this is your junior high school math teacher, and in this video I'm going to discuss solving problems applying the properties of quadrilaterals. So first thing we need to discuss, the first set of problems that I'm going to discuss is about the application of properties of parallelograms. So let us proceed immediately to some illustrative examples. So we go now to problem number 1 and let us read this problem. So the measure of one angle of a parallelogram is 80 degrees. What are the measures of the other angles? So for our solution, let us try to draw a quadrilateral and we assume that this four-sided plane figure is a parallelogram. And one of its interior angles is given as 80 degrees. Now the other three angles are unknown, so let us find the measure of each of these three. So we assume that these unknown angles are denoted by small letters x, y, and z. And let us label these unknown symbols for the three unknown angles to this quadrilateral. So to solve this problem, we apply some properties, particularly when it comes to the relationship of any consecutive angles of a parallelogram. So based on the property, in a parallelogram, consecutive angles are supplementary. Therefore, we can set up this equation. X plus 80 is equal to 180 degrees. So from this equation, we can solve for x, and that is equal to 100 degrees. Next, for the value of the other two unknowns such as z, we can set up this equation. Z plus 80 degrees is equal to 180 degrees. Again, we are applying this particular property. Consecutive angles are supplementary. So this is the reason why we set up this equation. And from this equation, we can solve for z, and that is equal to 100 degrees. Next, for the remaining angle denoted by y, we can set up this equation, or we could apply another property, and that is opposite angles in a parallelogram are congruent, meaning the opposite angles are equal in measure. Therefore, we can set up this equation as y equal to 80 degrees. Therefore, the measure of the other angles are what? 100 degrees for x, another 100 degrees for z, and y, which is equal to 80 degrees. For our next problem, in a parallelogram ABCD, segment AB, or the length of segment AB is thrice the length of segment BC, and its perimeter is 160 centimeters, meaning the perimeter of this quadrilateral. So we're going to find the lengths of all the sides. For our solution, again we draw a parallelogram and we name this as quadrilateral ABCD. And based on the problem, we assume that the length of segment BC is x. And on the problem, there is a condition, and that is AB, or the length of segment AB, is thrice the length of segment BC. Therefore, if BC is x, we can therefore express AB as what? 3x. Okay? since it is already stated in the problem that the length of segment AB is twice the length of segment BC. And for the perimeter of the parallelogram, we have 2AB plus 2BC is equal to 160. But AB is equal to 3x. Therefore, we can plug in the equivalent of AB and BC since BC is x and AB is 3x. So we can plug in their equivalent lengths to this equation so that we could form an equation in terms of x, which is this one, no? 2AB, that is your 3x since AB is 3. That is 2 times 3x since 3x is your AB. And 2, which is this one, times BC, which is x, equals 160 degrees. So at this point, we have just formed a linear equation in one variable x. So if we're going to simplify the left side of this equation, so that the equation becomes 6x plus 2x equals 160. And at this point, we can solve for x from this equation. So the left side can be combined since the left side has two similar terms. So 6x plus 2x is 8x, which is equivalent to 160. And we divide both sides of this equation by 8 to eliminate 8 from 8x, so that the left side will become x, which is now equal to 160 divided by 8, and that is 20. So at this point, we have just solved for x, and the value is 20. Then, from this obtained value of x, we can now compute for the length of each of these four sides. So for segment BC, that is equal to 20 centimeters, this one. And for AB, using 3x, 3 times the obtained value of x, which is 20, so that will give you 3 times 20 equals 60. Therefore, AB is 60 degrees. And since opposite sides are congruent, we can therefore say that, or we can therefore conclude that AB is congruent to its opposite side, which is DC. Therefore, DC is also equal to 60 degrees. And similarly, AD is also congruent to segment BC. Therefore, DC is 60 degrees. And AD is also 20 degrees. So these are the lengths of the sides of this parallelogram. Next, for our third problem, diagonals of parallelogram WXYZ intersect at O. If WO is 2B plus 2 and OY is 4A, OX is 3B plus 1, and ZO is 5A, find the length of these two segments, which are actually what? The diagonals of this parallelogram, WXYZ. So for our solution, let us draw the quadrilateral WXYZ, and we assume that this quadrilateral is a parallelogram whose name is quadrilateral WXYZ with diagonals WY and XZ. And along this diagonal, or first, you will notice that the diagonals from this quadrilateral intersect at what? Point O. And we're going to label the given lengths of the segments from these two diagonals. But first, the property that we're going to apply here to compute for the length of these two diagonals is this. The diagonals bisect each other. So meaning point O is the midpoint of each of these two diagonals. Therefore, if this is your diagonal, this segment, WO, is congruent to OY. Okay? And similarly, okay, or simply WO equals OY. And we label the given length of those segments. So WO is 2B plus 2, this one, and OY is 4A. Then, now, then for the other diagonal, okay, so first is we rewrite this formed equation into the form of 4A minus 2B equals 2, meaning we isolate those terms in terms of A and B, and we put them on the left side, and we retain the constant term on the right side. Okay, again, we put the term in terms of A and B to the left, and we retain the constant term, or we put the constant term 2 to the right, or we apply what? The symmetric property, which means that we interchange the position of the left and the right side in order to rewrite this formed equation to the form of uh, two terms found on the left and the constant term to the right. Ayan. Next, since 2 is common to each of the terms on both sides of the equation, so it will now be reduced to 2A minus B equals 1. Okay? Then we consider, or let us label this as equation 1. Then we form another equation which is taken from the other diagonal, Zx or Xa. Since O is also the midpoint of this segment, we can therefore say that ZO is equal to OX. Okay, this one. Of course, they are congruent, meaning this length here is the same as the length of this segment right here. So ZO equals OX. Then plug in the equivalent of their lengths. So ZO is what? 5A, while OX is 3B plus 1. Then we rewrite the equation, isolating those terms in terms of A and B to the left, and we retain the constant term 1 to the right. And at this point, we could label this equation as equation number 2. So at this point, we have just formed a system of equations in two unknowns A and B. And at this point, we can solve these two labeled equations simultaneously. So we solve for A and B. So first thing we need to do is to multiply equation 1 by 3. So the result would be what? 6A minus 3B equals 3. And let us label this as equation 3. And we're going to subtract this equation by equation number 2, which is 5A minus 3B. Now, if you will notice from this equation, 3B are identical from equation 3 and equation 2. So we could eliminate this term by means of subtraction. So term by term. So 6A minus 5A is A. Then negative 3B minus negative 3B is 0. Then 3 minus 1 is 2. So at this point, we have just solved for A, which is equal to 2. Then from equation 1, since A is equal to 2, we can therefore plug in the value of A from equation 1 in order to solve for B. This one, no? This one. So So this one right here is the value of A is replaced by 2. Yeah. Then we solve for B from this equation, and we have what? Yun. So B is equal to 3. And from the obtained values of A and B, we can now compute for the length of the two segments, WY and XA. So we're going to apply the segment addition postulate, which states that the length of WY is equal to the sum of the lengths of segment WO and OY. And that is 2B plus 2 plus 4A. This is for OY and this is for WO. And we substitute the values of A and B to this expression. So this is the resulting expression. So we simplify this applying the PEMDAS rule, or the order of operation. So WY is equal to 16. For XA, applying the same segment addition postulate, so that is equal to XO plus OZ. And for XO, that is quantity 3B plus 1 plus OZ, which is 5A. Then substitute the value of A and B to this expression and simplify the resulting expression using the PEMDAS rule or the MDAS rule. You will notice that the length of segment XA is 20, and this is our answer. Okay? Next, for number 4, probably this is the last example from this video. So let us solve this. Find the area of a rhombus DEFG if DF, which is obviously a diagonal, has a length of 12 centimeters, and EG, which is the other diagonal, has a length of 8 centimeters. Now for our solution, again, let us draw a quadrilateral and let us assume that this is a rhombus. And this is quadrilateral DEFG. Now, since segment DF and segment EG are the given diagonals, we can compute for the area of a rhombus using this formula. The area of a rhombus is equal to 1/2 the product of the two diagonals. Okay? By substitution, we have area of a rhombus is equal to 1/2 of DF times EG. And we know that DF from the given is 12, while EG is 8. So 1/2 the product of 12 times 8 is 48 square meters, and this is our answer.